In this lesson, we're going to expand a little bit on vertical motion and talk about falling objects. Student learning objectives apply what we know about vertical motion to model falling objects. And the essential questions for today's lesson: what is special about falling objects and how can we model it? So when talking about falling objects, there are two important things to remember or just to know before we start. So the first thing is the initial velocity is going to be 0. So why is that? Because the object is being dropped. So it's not being thrown up at all. So it doesn't have any, velocity going upwards or any speed going up. And it starts in place. And it's not being thrown down either. It's just dropped. It doesn't have any velocity until gravity starts acting on it, or until it's dropped. So it starts in place. And because of gravity, it starts falling immediately. But before that, it's not moving at all. Think about dropping a penny off the Empire State Building or dropping a ball from your bedroom window. And the second thing to make sure we understand is that there will always be a starting height. If something's falling or it's dropping, it means it hasn't hit the ground yet, or it hasn't hit a certain height that we're looking for yet. So most of the time, things will be dropped from a certain height. And we will use the vertical motion equation to model the flight of the object, and more importantly, how long it is until the height is 0, or when the object hits the ground. So the ground is usually 0. We may even use this model to see how long it would take for it to reach a certain height. It doesn't necessarily have to, the height we're finding the time for doesn't necessarily have to be 0, but it will always have a starting height. If the object starts on the ground, then the height is 0. And that doesn't make much sense. If something was on the ground, it wouldn't fall. It would just stay on the ground. Here's a real-world example of a problem. Say an acorn falls from a tree branch from 64 feet in the air. How long will it take until it hits the ground? So we start here with our vertical motion equation. H equals negative 16 t squared plus vt plus h sub 0. 0, that's the height. So I want to find out how long it will take until the acorn hits the ground. So at the ending point of this problem, the acorn will be on the ground, or the height of the acorn will be 0. So that's what I'm going to put in for h. My height of the acorn, I want to be 0. Okay? Equals negative 16 t squared. Now I don't change anything for t because that's what I'm finding out. How long? So that means time. What's the time frame of from when it drops to it hitting the ground? How many seconds is that? So I don't substitute anything in for t. That's what I'm looking for. Plus 0t, like we just discussed on one of the previous slides. If it's being dropped, that means it has no initial velocity. So I'm going to put a 0 there for my initial velocity, and therefore this middle term will actually disappear. Again, I don't put anything in for t, but because anything multiplied by 0 is 0, this term will be 0, so we can get rid of that. And then our starting height is 64 feet in the air, so plus 64, that's my h sub 0, my initial starting height, my initial height. Don't get that confused with the height in which I'm finding how long it takes the acorn to get there. This will always be the same. This will be your starting height. Okay? So I'm going to get rid of this term. I'm going to subtract 64 from both sides. I'm going to add 16t squared to both sides, and I'll get 16t squared equals 64. I am going to divide each side by 16, and I get t squared equals 4. If I take the square root of both sides, I get t equals plus or minus 2. So since we started the timer at 0, and there's no such thing as negative time, therefore we only have one answer. Even though algebraically it gives us positive or negative 2, it just doesn't make sense to have negative time. So we only take the positive answer. So our answer is the acorn will hit the ground after 2 seconds. And that's all I have for you for this lesson. I hope you enjoyed yourself. Hope you learned some things. Go ahead, try your homework assignment. If you have any questions, feel free to contact me on BBIM or send me a text message or an email, whatever's easier for you. And make sure you come to live class and we can go over a couple more problems. Thanks.